Greetings. This video is about the study on the economic and environmental impact of increasing the compressive strength of concrete in the design of reinforced concrete structural frame of a 4-story building. Many of the world's famous structures are made of concrete. Concrete is the most consumed building material and the second most consumed material in the world after water. It offers the construction industry with characteristic properties such as high compressive strength, versatility, non-combustibility, and high durability. The world production of ordinary Portland cement is about 3 to 4 billion tons per year, and it is projected to increase by 216% between now and 2030. Large volumes and the energy-intense production of Portland cement with clinker as main source of carbon dioxide, emits about 2 billion tons of carbon dioxide per year and corresponds to 8 to 10% of anthropogenic emissions in the world, and could reach 10 to 15% by 2020. Mining large quantities of raw materials and aggregates often results in extensive deforestation and topsoil loss, and adversely affect the ecology of forested areas and riverbeds. Additional environmental strain is due to numerous chemical and mineral admixtures, which need huge inputs of energy and materials into the final product. Also, batching, mixing, transport, placement, consolidation, and finishing of concrete operations are energy-intensive, wherein fossil fuels are the primary source of energy. So now, how to address these concerns? First is to reduce the consumption of concrete by developing innovative structural design and using highly durable materials. The carbon dioxide from the calcination in clinker production could potentially be reduced by using carbon capture and storage. Also, the carbon dioxide from combustion of fuels could be reduced by improving the energy efficiency of the production process by using bio-based fuel. Another would be use of supplementary cementitious materials and superplasticizer. And last would be the use of alkali-activated cement and use of recycled aggregates. But, what else can be done? That is what we will explore in our study. We will look at the effects of increasing the concrete compressive strength as applied to a reinforced concrete structural frame of a 4-story building. Using 4,000, 6,000, and 8,000 psi concrete, the study results to a design with reduced column and beam dimensions. The table shows the percentage difference of columns cross-sectional area upon increasing the compressive strength. And the table shows the percentage difference of beams cross-sectional area upon increasing the compressive strength. Now let us check for the environmental impact on the global warming potential characterized by CO2 and ozone depletion potential characterized by CFC11. Also, how the increase in compressive strength influence the cost. Environmental impact will be evaluated through a life cycle assessment. LCA is a systems analysis tool for evaluating environmental impact of a product or service during the whole life cycle, from raw material acquisition to final disposal as per ISO 14040. CIMA Pro, the most widely used among the LCA software, will be used to aid in the evaluation. A cradle-to-gate approach will be used, that is, material manufacturing and construction including transport. And now for the results. The evaluation for the global warming potential gives an increasing trend with the increasing concrete compressive strength. The bigger difference is between 6,000 psi and 8,000 psi. Very little difference is observed between 4,000 psi and 6,000 psi. As for the ozone depletion potential, the evaluation shows a decrease for both the 6,000 psi and 8,000 psi compared to the 4,000 psi. The bigger difference is between 4,000 psi and 6,000 psi. Very little difference is observed between 6,000 psi and 8,000 psi. In terms of the estimated cost for the structural frame, The 6000 psi and 8000 psi are both lower than the 4000 psi, with the 6000 psi the lowest of the three. The use of concrete is inevitable in the future. Reduction of its environmental impact will be a continuing effort for a sustainable development. Further study is needed to meet a growing need for more concrete without compromising the environment.